Alright, in this video we're going to find the inverse of a 3 by 3 matrix using the determinant and matrix of cofactors. Now there are other ways to do it, but I don't think they're as good, and they're more complicated, so no one likes things being more complicated, especially me. So if we take our original matrix, you might recall the videos telling us how to find the determinant and matrix of cofactors. You need to be able to do this, so I'd recommend watching my other videos if you don't know how to do that. We find the determinant of our matrix. In this case, it ends up as being 38. Then we find the matrix of cofactors, and once we have the matrix of cofactors and the determinant, we can do something with them to find the inverse matrix. So that's what this video is all about. So if you take the matrix of cofactors that you've worked out, then what we need to do is transpose it. So each row will become a column, and by doing that each original column will become a row. So that's all we're doing. We're making rows and turning them into columns. So this matrix of cofactors, if we transpose it, it'll end up looking like this. And this is called the adjoint, or more correctly called the adjugate of matrix A. So we started off with matrix A, we found the matrix of cofactors, which we usually call C, and then we made each row of it a column, and that is then called the adjugate. And we denote it by putting the T superscript above the C. The matrix of cofactors transposed is just known as the adjugate. Okay. Once we've got the adjugate, which is the transposed matrix of cofactors, we divide it by the determinant, which is the same as multiplying it by 1 over the determinant, because multiplication and division are inverse operations. So this is telling us that the transpose of the matrix of cofactors times 1 over the original determinant is actually the inverse of the original matrix. So the adjugate of A, which is also known as the transposed matrix of cofactors, times 1 over the determinant of A is the inverse matrix. So we take, I'll just write this out again, our matrix of cofactors, and as it says on the left, you need to take it and just multiply it by 1 over the determinant, which is effectively dividing it by the determinant, whereby the determinant looks like a scalar multiplier on the outside of the matrix. And it's as easy as that. So let's try a real life example. We're going to find the inverse of a 3 by 3 matrix. Step 1, like I said, find the determinant. Step 2, find the matrix of cofactors. Step 3, make each row of the matrix of cofactors a column. So and that is called the adjugate. And then all we need to do is multiply the adjugate by 1 over the determinant, and that is the inverse of the matrix. Let's have a go. Alright, so the first thing we're going to do is find the determinant of matrix J, which we denote like that. So with the determinant, you multiply each element in the first row by the minor matrices when you ignore its row and column. So it's going to be 1 lot of 4 times minus 5, take away 6 sixes. So that'll be minus 56. For the second element in the first row, it'll be minus 2 lots of the diagonals when you ignore minus 2's row and column. So it'll be minus 2 times minus 3 lots of minus 5, take away 2 sixes. So that'll be minus 2 lots of plus 15, because the two negatives cancel each other out with multiplication, and take away 12. So that's minus 2 lots of 3, which is like 3 lots of minus 2, which is minus 6. So that's minus 6. And next we have the third element of the first row. So we take that 5 and we multiply it by the diagonals of what's left. So it'll be 5 lots of minus 3 times 6, take away 2 4s. And that comes out as being 5 lots of minus 18 minus 8, which is 5 lots of minus 26, which is of course 5 lots of minus 20 plus 5 lots of minus 6, if you want to see it that way. And remember, every other element in the determinant and the matrix of cofactors has to have its sign changed. So the second one, the element corresponding to the minus 2 is changed from minus 6 to 6. So now the determinant itself will be minus 56 plus 6 minus 130, which is minus 180. So that is the determinant. So we've done that so far. Next is the matrix of cofactors. It's similar. You take each element and multiply the minor diagonals, but we don't multiply the element by the mini determinant, if you know what I mean. We don't multiply the 1 by the 4 minus 5s minus 6 6s. We just find like the mini determinant of the mini 2 by 2 matrices, and they are called the cofactors. And then later on what we'll do is change the sign of every other element. So the first one's minus 56. Element, the minus 2 gives us minus 3 times minus 5, take away 2 times 6, which is plus 15, take away 12. It looks a bit familiar because this was similar to what was in the determinant. And the third element will be the cofactor of 5 will be minus 3 times 6, take away 2 4s. That's minus 18, take away 8. Which is a minus 18 made 8 more negative. And remember, the minus sign just means move to the left. So that is minus 26. The minus 3 element in the second row first column, that will give us minus 2 times minus 5, take away 6 5s, which is 10, take away 30. That's minus 20. And all I did, just to remind myself, for the minus 2 element, I changed the answer to minus 3 from 3, because that will remind me to make every other element negative if it's positive later on. So we changed the sign of every other element in the matrix of cofactors. Element 4 comes out as minus 15. Element 6, its cofactor will be one lot of minus 5, sorry, one lot of 6 rather, take away 2 lots of minus 2. So we're going to be taking away a negative, so it's 6 take away minus 4, is 6 plus 4, which is 10. Bottom left element gives us minus 2 times 6, take away 4 times 5, which is minus 12, take away 20, makes it even more negative, minus 32. Third row, second column, element 6, its cofactor will be one lot of 6, take away minus 3 lots of 5. So that's 6 take away minus 15, which is 6 plus 15. And then the final element, its cofactor will be 1 times 4, take away minus 3 times minus 2. So that'll be 4 take away plus 6, which is 4 take away 6, which is minus 2. And like I said earlier, every other element we have to change its sign. So if it was positive, it becomes negative, and if it was negative, it becomes positive. So that 3 will be a minus 3. Minus 20 will actually become plus 20. 10 will become minus 10. And 21 will become minus 21. So now we have all the cofactors themselves, so we can make the matrix of cofactors and just put them into a matrix. We've got minus 56, minus 3, minus 26, 20, minus 15, minus 10, minus 32, minus 21, and minus 2. So that is the matrix of cofactors from our original matrix. The next step is to transpose this, so we make each row, we take the first row and we make it the first column, or take the first column and make it the first row. It's the same thing. So as long as you take each column in turn and make it a row, or take each row and make it a column, you will end up with the transpose of the matrix of cofactors, which is known as the adjoint, but more commonly known as the adjugate. So once we've taken the matrix of cofactors, we make each row a column, and this is called the transpose of the matrix of cofactors, also known as the adjugate. And in order to find the actual inverse, all we do is we multiply the adjugate, which is the transposed matrix of cofactors, we multiply that by 1 divided by the determinant, which is the same as dividing that whole matrix by the determinant. And that is the inverse. So the inverse of matrix J, if we want to tidy it up, if you've got a negative scalar on the outside, you can just change it to a positive and change the sign of everything else on the inside. It's like multiplying both by minus 1. You notice how it's now 1 divided by 180, whereas the determinant was minus 180. So I've just flipped the sides because it looks a bit cleaner to have a positive determinant on the outside, and that is the inverse. So it was as simple as that, really. It's a long kind of process, but as long as you stick to the rules, you'll always get it right. Watch out for negative products, and remember to make every other element of the matrix of cofactors change its sign. So if it's minus, make it a plus. If it's a plus, make it minus. So we found the determinant, we found the matrix of cofactors, we transposed the matrix of cofactors to make the adjugate, and then we multiplied that by 1 over the determinant. I hope this has been useful. If you've got any questions or comments, please leave them below, and keep watching Maths4Engineers for any more videos. Cheers.